In any data model, it is important to distinguish between the description of the data, or data definitions, and the actual data itself. The database scheme provides the description of the data. It specifies the various data concepts, their relationships, constraints, etc. It is specified during database design and is not expected to change too frequently. It will be stored in the catalog, which is the heart of the DBMS. The database state then represents the data in the database at a particular moment. It is sometimes also referred to as the current set of instances. Depending upon data manipulation such as adding, updating, or removing data, it will typically change on an ongoing basis. Here you see an example of a database scheme. We have three data concepts: student, course, and building. A student is characterized by a number, name, address, and email, a course by a number and name, and a building by a number and address. These are examples of data definitions which together make up the database scheme stored in a catalog. Here you can see an example of a corresponding database state. You can see that the database includes data about 3 students, 3 courses, and 3 buildings. The tree-scheme architecture is an essential element of any database environment or application. You can see it illustrated in this figure. Let's start with the middle layer. Here we have the conceptual data scheme. As mentioned before, it focuses on the data concepts, their relationships, and data constraints without bothering about the actual DBMS implementation. It should be a user-friendly and transparent data model constructed based upon a close collaboration between both the database designer and business user. It will be mapped to a logical data model based upon the implementation environment. Hence, the middle layer includes both the conceptual as well as the logical scheme. The latter will then be physically implemented using an internal scheme specifying which data will be stored how and where. The top level represents the external scheme. Here, views can be defined which offer a window on a carefully selected part of the conceptual model. The external views will be tailored towards the data needs of an application. A view can serve one or more applications. As an example, think about a view offering only student information to a student registration application, or a view offering only building information to a capacity planning application. To summarize, an external view or scheme describes the part of the database that a particular application or user group is interested in, hereby hiding the rest of the database. It thus allows to control data access and enforce security. The conceptual scheme specifies the data concepts, characteristics, relationships, integrity rules, and behavior. Finally, the internal scheme specifies how the data are stored or organized physically. Ideally, changes in one layer should have no to minimal impact on the others. This will allow to physically reorganize the data with minimal impact on the conceptual or external layer. Likewise, changes to the conceptual or logical model can be made with minimal impact on the external layer. Here you can see the 3-layer architecture illustrated for a procurement business process. The middle or conceptual layer defines the data concepts such as product, customer, invoice, and delivery. The internal or physical scheme contains the physical storage details. The external scheme has three views, offering specific information to the finance, customer service, and logistics department. It is clear that this three-layer database architecture has several advantages in terms of efficiency, maintainability, performance, security, etc. As already mentioned, the data dictionary or catalog constitutes the heart of the DBMS. It contains the data definitions or metadata of your database application. More specifically, it stores the definitions of the external, conceptual, and physical scheme. It also synchronizes these three schemes to make sure their consistency is guaranteed. Various types of users interact with the database. A database designer is responsible for designing the conceptual and logical scheme. He or she will closely interact with the business user to make sure the data requirements are fully understood and modeled. Based upon the logical scheme, the database administrator or DBA will design the external and physical scheme. He or she will also set up the database infrastructure and continuously monitor its performance by inspecting key performance indicators such as response times, throughput rates, and storage space consumed. The application developer will develop database applications in a general purpose programming language such as Java. He or she will provide the data requirements, which will then be translated by the DBA to view definitions. The business user will run these applications to perform specific database operations. He or she can also directly query the database using interactive querying facilities for reporting purposes. Finally, the DBMS vendors offer the DBMS software packages. Popular examples are Oracle, Microsoft,